Okay. The videotape is and will be used at owner-operator's own risk and is not intended, nor is it to be used as a substitute for disseminating and practicing safe operating procedures in accordance with industry standards, training, safety instruction, and operation and maintenance manuals, and especially in view of possible further changes, additions, or improvements to said procedures. Non-attendees of this training are not considered qualified to work on equipment by viewing the training video alone. Accordingly, Schneider Electric assumes no liability for the completeness nor accuracy of the videotape, any claim for injury or property damage which arises out of or in connection with the use of the videotape by the owner-operator, any of its employees that have not participated in the training, or its agents, is the sole responsibility of the owner-operator, and the owner-operator agrees to hold Schneider Electric harmless. I'm Sean Scott. My name's Sean Scott. I'm with Schneider Electric. I've been with Schneider for 25 years. I'm a field service tech, so I'm one of the guys that comes out and works on this equipment, so I know it pretty well in and out. If you have any questions, feel free to ask them. And I'll work from left to right, from the medium voltage end right down through the end. This is our HVL, we call it an HVL. It's a medium voltage, enclosed medium voltage switch. One thing you'll find on all of our equipment, we have a factory order number. It's going to be on the nameplate of all the equipment, the factory order number. The first 2 digits are a code for the factory that made it. This was made in Smyrna, Tennessee, right outside Nashville. The next 8-digit number is we call it either a factory order number or a quote to cash number. It's a number that is associated with all the switchgear on this order. And then specifically this piece of equipment is the next 3-digit number, 001. So if you're calling Schneider for technical support, you'll need to have, or parts support, anything along those lines, you'll need to have this number to reference what you're talking about. Below that is the part number for this switch specifically, manufacturing date, and then it goes on to the different ratings. This is 5,000 volt rated. Impulse voltage rated is 60 kV. Interrupting rating is 18 kA, 60 hertz. Also on this is going to be your fuse sides. You had the fuse part number for the fuses in here and the fuse size. It's a 450 amp fuse. You'll see all electrical equipment has all kinds of danger labels. This one's no exception. When you operate this switch, you can look in through the window to see the switch contacts. And this is telling you that the switch blades can stick in. So you open the switch, you think it's open. I don't know if you can see that or not, but this is showing the switch blades open. This is showing the arc tips still stuck in the arc chute. If the arc tips are stuck in the arc chute with the handle open, that means all this is now still live. So you have to, when you open the switch, you want to look in through the window, verify if the blades are all open, and obviously if you're going to do work in there, that's when you would want to check it de-energized with a properly rated voltage tester. The way the switch operates, right now you have a Kirk lock. This key should normally be held down in the breaker. I'm not sure why you don't have the lock in the breaker. The drawing shows you have one. We'll have to get that worked out. But that Kirk lock is built to, it would be installed in here and held in here if the breaker's closed. So to open that switch, you would have to come down here, open this breaker, lock it open, bring the switch down here, or the key down here to the switch. If you notice right here, without the key in the cylinder, the shaft is going up into the operator. That's going to prevent this switch from being operated right now. So with the breaker open, locked open, release the key, you'd be able to come down here, put it in the cylinder, retract the shaft, and then you could open this switch. The purpose of that is to minimize the load on this switch when operating. This is a load break switch, so it's rated to interrupt the load, but the number of rated operations between servicing is dramatically different if you're operating under load, if you're operating under no load. So the whole purpose of this key interlock is to prevent you from operating under load, to minimize wear on the switch. When you open the switch, you pull the handle down right through the normal travel. The way this mechanism works, it's an over toggle mechanism. As you're pulling this down, you're compressing a spring. Once you go over top dead center on the spring's going to unlatch. It's not really latch, but it's going to go over toggle and release, and slamming the blades open in a quick move. So you don't want to pull gently until over toggle and bring it down. You just want to bring it down in one quick motion. When the switch blades open, you have the main blades, and to the right of those you have the arc tips. The arc tips are in the white housing. Those are the arc chutes. As the blades open, the arc tip is stuck in the arc chute, and it's on a spring, so as the blade comes open, the arc tip's going to stay in the arc chute. Once the movable blade is free of the stationary assembly, then the arc tip will pivot down and come out. And that's to generate any arc, or keep any arc minimized to the arc tips instead of on the main blades. Every switch, every load break switch, any circuit breaker has an arc tip assembly. And they pretty much all work the same on switches. So on the opening, the main blade comes out. Once it gets far enough, the arc tip slips out, and you'll see the arc at the arc tip. On the closing, it works the same way, except for backwards. You have the same over toggle mechanism. The switch handle is going to be here. You're going to bring it up. You're compressing the string. It goes over top dead center and releases, slams the blades in. When the blades go in, the arc tip and the main blade go in together. Inside the arc chute, there's electrical contact out further, so it's going to make electrical contact in the arc chute before the main blades make up. And below the main switch is the fuses, and you have cable connections over to the transformer. Anyone want to look in here, see what we're talking about, or any questions about this yet? No? You do have a maintenance accessory on the side of the gear. It's a fuse puller. Obviously, you would never pull these fuses out live. You'd have the switch open, locked, and you have a hot stick to pull the fuses out. This key interlock also, it'll prevent you from opening the switch without the key, but it also prevents you from closing the switch without the key. You never want to open or close the switch with the main breaker in and closed, just to minimize load on the switch when you operate it. So you're going to have 3 cable connections off the bottom of the switch coming in here. They're 5 kV rated cable. They're non-shielded. If you look in there and see, those cables should always be about 4 or 5 inches apart. They are fully insulated, but any medium voltage non-shielded cable needs to maintain 4 to 5 inch clearance between phase to phase or phase to ground. Cable will come up here into the coils. You're going to have 3 coils. This is just a dry transformer. Dry transformers. Anyone have a pocket crescent wrench? You have a temperature controller to monitor and start fans in the event the transformer gets hot. The biggest limitation on a transformer is heat. It generates heat, you have to dissipate the heat. In the transformer, again, you have the nameplate here. You have a serial number. The serial number is the same quote to cash number. Same 8-digit number that we saw here, it's going to same be 8-digit number there. Then the 3-digit 3-digit number to tell you specifically what we're talking about. So 2000 kVA transformer takes 4,160 volts, transformer it down to 480, 277. You have multiple taps on the transformer. If you find that your voltage isn't what you need it to be, high or low, you can shut down the switchgear and change the taps to accommodate that. These transformers are all made in Bland, Virginia. There's not much to do with the transformer. We may recommend, like the switch, we recommend maintaining it once a year. Vacuum the coils. We recommend, we highly discourage use of compressed air when you're cleaning a transformer. Some people will do that. What we've found is you can drive dirt and dust into crevices in the transformer that you're never going to get it out of. So it's best to just wipe it with clean rags and vacuum. The fan controller, Model 98 temperature controller, like I said, it monitors and starts the fans that also give alarm. It's going to continuously scroll through the 3 coils and tell you what those temperatures are. This is a 150 degree C transformer at can't remember what the set point is, we can look it up later, but at some set point it's going to cycle the fans on. You'll have a light that comes on right there where it says fans, that'll show you the fans are running and you'll hear them run. Somewhat above that is going to be an alarm will come on. It's an audible and visual alarm, and there's also a trip contact. Trip contactors, I think, runs about 220 degrees Celsius. It's not wired into anything, so nothing's actually going to trip, but if you're into the fan loading of the transformer, you could wire it in to trip the main breaker to unload the transformer. This controller also will start and run the fans for 1 minute every 7 days. From the day it was energized, exactly 7 days later, it's going to start and run for a minute. It's just an exercise circuit to keep the fans from seizing up. Any questions? Move down to we call this PZ4, Power Zone 4 style switchgear. It's 480, 277. It's built to be compartmentalized sections. You have the front section of the gear where you're going to find the breakers, control components, metering, communication. Then behind the front section is the bus compartment. Bus compartment is not accessible through the front at all. If you come in through the back, you'll see the first thing you get to is a cable compartment, and then the bus compartment's going to be isolated. Here in the way we lay these out, we have sections 1, 2, 3, 4, 5, cubicle A, B, C, D. So this would be cubicle 2, and it's 2BC because it takes up 2 sections. This first section here, you have a transient voltage surge suppressor. This is just a display. The actual TVSS unit is in the back of the cable compartment. The other thing you have in this section is you have taps ahead of the main breaker to go over to the fire pump controller or fire pump breaker right there. The fire pump breaker is normally taps off ahead of the main breaker, just so that if you have any, if your building's on fire and you trip off your service, you still want to have power for the fire pump controller. The other things in this first section are just the metering base unit. There's a DC power supply, some fuses, and a fuse disconnect switch. A fuse disconnect switch is for the meter, and it's going to also, actually that may not be, so the control power transformer is probably here. We also have a control power transformer that supplies all the control power for the lights on the breaker and any other control functions you have in the gear. As you go through the gear, you have any interconnections between this section and other sections. We'll go through a wiring trough in the top and a wiring trough in the bottom. During maintenance, it should be opened up and cleaned, checked. What I've seen over the years is mice will get into these wire compartments and they seem to just enjoy chewing on the wires.
Insulation, right?
Yeah, it's delicious, apparently. So after section 1, you come to section 2. This is your main breaker. This is our master pack breaker. We'll go through it. We'll pull the spare breaker out and look at that a little more in depth. But just going through the front of the breaker, you have the nameplate, tells you what rating, what frame it is, and what rating it is. This is an NW style breaker. It's rated at 3200 amps, and it's rated, the interrupting rating is H1, which happens to be 65 kA. You operate the breaker, open and close right here. Right now you can see it's closed. You're carrying 240 amps load. Right here in this flag here, this is your spring charging indication. If you look, all the breakers that are closed have a little yellow flag that say charged, but it also says not okay. What that means is it's not okay to close right now. In this case, it's not okay to close because it's already closed. There's been some concern, I've gotten concerned calls over the years that my breaker says it's not okay. It's not that the breaker's not okay, it's just not okay to close. If the springs are charged and the breaker's closed, it's not okay to, because it is already closed. There's a few other things that can drive that. If the breaker was open and you had the padlock attachment pulled out and the springs were charged, you'd see charge not okay. If you're holding the open button and the springs are charged, you'll see charge not okay. If the breaker is tripped, when the trip unit trips the breaker, this red button pops out. If the red button's popped out, it's going to say charge not okay. If your racking handle is installed, the breaker's interlocked off and it's going to say charge not okay. You can have a shunt trip which trips the breaker through controls. If that's in and energized, it would say charge not okay. Or if you have an under voltage coil that's not satisfied, it would say charge not okay. Again, this is a padlock attachment. The Kirk key that should match the HVL should go here. And then this is a trip unit. This is we call it Micrologic 6.0P trip unit. Micrologic is just our name for trip units. 6.0 is telling us that it's a ground fault trip unit. And P says it's power. It gives you power readings. If you look at your meter button here, you can go in here and you could select to look at current, voltage, power, energy, or frequency. instantaneous voltages. So you got those all there. The voltage indication comes off the bottom of the breaker. It's internal to the breaker, but it's on the bottom of the breaker. So if this switchboard was energized, but the breaker was open, you would not see voltage here. The way the power comes in, you're going to have bus connections up here, going to come over here, down through the breaker, and then out through the rest. So the line side of the breaker is at the top, the load side's down here. These would be open, these would be de-energized if the breaker's open. This warning tag here talks about those voltage taps. It's telling you that you cannot measure the bottom of this breaker. You can't measure the bottom of any of these breakers. These all have P-trip units. There are physical connections to the bus. If you measure it without following these instructions, you're just going to show a short phase to phase. You can also damage the trip unit. In order to, if you needed to measure the switchboard or the breaker or the switchboard, all you'd have to do, and it tells you there, is pull this rating plug out. You back it out, the connections, the voltage connections to the trip unit go up through there. This would isolate those voltage connections. Other function you have here on the trip unit, you have the wrench, that's maintenance. You have history logs. If the breaker trips, you can come into the history log and go to trip history, and it'll tell you all the date with a date time stamp, all the times it's tripped. Showing here that you had a ground fault trip on April 30th of this year. If you want to know more information about it, you push the enter button, and it's going to give you again the date time stamp and what the current was. This likely was during testing. Yeah, testing was done April 30th. The ground fault trip happened on April 30th. It was just for testing. Any other setup of the breaker, the trip unit, can be done through here. You have metering setup, you have comm setup, micrologic setup. You can change the date time here if you needed to. Third button over here is your protection. That's showing a trip curve. You push that. Amperage protection, those values are set down here on these dials. They can be fine-tuned through this. We're showing current protection. This is showing, right now your long time setting is 3200, and that's determined by this dial here. 1.0 times 3200 is your setting. The next value down is 0.9. So if you were supposed to set a setting somewhere between 0.9 of 3200 and 3200, you could dial it to 1, and then you could scroll down to the 3200, select it, and then you could fine-tune it with these keys here. If you change something, you're not going to change it accidentally. If you change something, even here I didn't actually change anything, I just went to the screen where I could change it. When I backed out, it's going to ask, do you want to save do you want to save the new settings? If you don't want to save it, just hit no and enter. So you're not going to ever accidentally change anything here. You're also not ever accidentally going to trip the breaker through here. So if you're coming in here in the middle of the night to try to figure out why a breaker tripped or what happened, you're not going to run any risk of tripping the breaker through these. Well, you would run a risk of tripping the breaker. There's a little white button here. That is a push test for trip testing the circuit breaker on ground fault. If you push this white button, the breaker will trip on ground fault. The other thing here you have is a port that's for testing the breaker. There's a test set, a couple different test sets available. You can plug in there, simulate load into the breaker, and have the breaker trip off on its protective functions. Okay, we'll come, the other thing we have here on the breaker, this is called a ERMS switch, energy reduction maintenance switch. What that does is, in the off position, it lets all the settings stay per the settings on this trip unit. In the on position, it's going to set the instantaneous down to minimum. Right now, your instantaneous value is set at 48,000 amps. So if this breaker sees 48,000 amps, it's going to trip off with no intentional time delay. If you take this ERMS switch to on, that's going to make your instantaneous setting go down to minimum, which is 2 times, so that'd be 6,400 amps. The reason you would do that is if you're working down here, racking a breaker in or out, doing voltage checks, anything working downstream of this, you'd set it to on, and that would minimize your arc flash out values that you could be exposed to downstream of this main breaker. It doesn't help you at all if you're racking the main breaker out, because all that's doing is making it so this will trip quicker. If you're racking this breaker out, this breaker isn't protecting you. You're protected by the line side or the transformer fuses. This breaker's already open. So it's kind of a common misconception that if you're racking this breaker out, you take the ERMS switch, you're doing something down here. The ERMS switch is only protecting you on anything downstream of what it's affecting. When you take the, what's that? I can't hear you.
Where's the tool racking in and out?
I was going to do that on one of the spare breaker. You have a storage spot here. This is a tool. At the Mohegan Sun Casino was the first gear back, I think in 2003, was the first of this switch gear we shipped up into the Northeast. The electrical contractors there thought these were great. They used them as nunchucks. When they're done with it, basically all of them were just this part. When you turn the ERMS switch to on, this light will come on blue. It closes the contact, which goes into a input-output module, which will then tell the breaker to go into ERMS mode. When the breaker goes into ERMS mode, it'll light this light up blue. It'll also, across here, it'll flash ERMS. You'll see an hourglass shape and then ERMS. We can do it now if you want, and there's really no risk to it. Hourglass, you're in RMS mode, and when you get here, it's going to flash periodically ERMS and then go back to normal. The only risk you have when you take this ERMS is now you may not have the coordination that you would expect to normally have operationally, because again your instantaneous setting was 48,000 before. Now it's 6,400. If you're starting a very large motor now while you're in ERMS, you run the risk of tripping the breaker. Light goes out, and then it's going to come back to normal, and it's just not going to say ERMS any longer. Now on the breaker here, we'll go in racking in and out here. Have you guys racked these in and out at all? You have? So you know the trick already? What the trick is, so we have a little legend play here to tell you what to do. Step one is push and hold the open button. Step two is push and hold the old button to get the crank in. When it's in, you know it's in because it's locked in place. Step two is pushing this gray button. This gray button is part of a position lock for this. it locks it in the disconnect, test, and connect or connected position. So you want to take it out of the disconnect and bring it into the test position. You push the gray button and start racking the breaker in. As you rack it in, see the arrow come around. What was happening there is it's control connections across the top. They plugged into the top of the breaker. Once they plugged into the top of the breaker, you supplied 24 volts DC to this trip unit to light it up, and supplied 120 volts to the spring charging motor. That's why the spring charged. I'm not going to rack this into the connected position because the bus is live. We're not geared up for that. But that's racking out into the test position. In the test position, like I said, the control connections are made up on the top. The 480 connections in the back are not made up. So when I'm going to open and close this breaker, we're not doing anything to the 480 side. Notice I had showed you here the flag there. This is when it's okay. So right now, if you push this button, it's going to close. Closing. Okay, now it's closed, not okay. Or charged, not okay. Opening. Padlock attachments here. You're doing lockout, tagout down for the downstream loads out of this. You just put your lockout, tagout lock there. Notice when I pulled it out, it goes charged, not okay. Closing. It says 6, but it might be 6 or 7. Okay, now we're closed. Push the test on the ground fault, tripped off on ground fault. Shows you your date time stamp. It's not showing any phase current because there was no phase current. Simulated ground current was 800 amps. Okay, so no, the breaker's open now, but it's still saying charge not okay. Saying charge not okay because it's not okay to close because your red button's popped out. It's tripped. This, resetting this, doesn't mean the fault's cleared. Whatever tripped the breaker, that doesn't mean the fault's clear. That's just one step we put in the process to aid the operator to make him think, is this really safe to close back in? It has, you know, it means nothing as far as whether the cause of the fault was corrected. We had an issue at, I think it was a Harvard facility years ago, that breaker tripped for some reason. They just closed the breaker back in immediately. Well, when the breaker tripped, the contractor had left a wrench in the switchgear. And the jumping of the switching, or the breaker opening, caused the wrench to fall down on the bus. So when they just closed the breaker back in, then it had a real fault. If you have a trip, you want to find and correct the fault before you re-energize it. So you reset that. The other thing, to reset that indicating light, you push the little test reset button. Notice when I push that, that cleared. To rack the breaker out, same idea. Push and hold the open button. Install the crank. Push the gray button. Bring it out. And when you get to any of these positions, once the button pops out, you're in that position. You can just stop racking. Older style draw breakers, it was kind of a feel when you thought it was in far enough, which led to a lot of people really torquing breakers in, causing problems with the cell. This, when the button pops out, you're in the position, you're done.
Gray button.
Yeah, gray button. If you walk in and you see one of these breakers with the button popped in. That's not a problem. The breaker's not going to vibrate out of the cell or not. It's just going to sit there. Some people will do that because they get all excited. They rack the breaker in to the test position, push the gray button, rack the breaker in to the connected position, and push the gray button again. That's not a problem. If you wanted to reset it, all you'd have to do just come out of position a little bit and reset it. Once you got the breaker into the disconnected position, you can withdraw it. You push these two tabs, pull out. As you pull out, notice the springs discharge. That's part of this cell interlock over here. Any draw breaker, as you pull it out of the cell, the contacts, you have to, when you pull it out to work on it, it's required by NEMA standards that the breaker will come out being open with any springs discharged. That's just a safety measure to make sure that someone doesn't stick their hands, pull the breaker out, stick their hands in and get it caught in the springs. So this is the fully withdrawn position. If you wanted to pull this breaker out now, you have the handholds here. You'd lower this down onto it. Just like that. The same operator will work for any of these breakers. So these are the controls, the secondary connections, control connections that drop down onto the breaker to bring the trip unit and the spring charging motor. You also have auxiliary contacts, spring charging, shunt trip, shunt close. This is an alarm contact. This is a 24 volt DC. These are communications and zone selective interlocking. These are the arc chutes. The arc chutes serve the same function as the arc chute does down on the switch back there. It absorbs and quenches the arc to prevent the main contacts from getting excessively worn. Now if you want to pop in and look at the main contacts, up here is the arcing contacts. The main contacts are down below. That's closed. There is a wear indicator for these contacts to show you if the contacts have worn. You can't see it now, you have to trust me that it's there. But if the contact's worn, you'll see a little line scribed in the plastic. If that becomes visible, that means your contacts are worn and the breaker needs to be replaced. Anyone else want to see them?
Man, that's not good.
We're okay.
That happens.
Fortunately, there's not any crevices for it to get into with the breaker closed. It would have been a bigger pain in the butt if the breaker was open right now.
It would have went all the way in, right?
With the magnet, you can still get it out, but and if you noticed or not, when I pulled the breaker out, you can see behind it, there's shutters. As the breaker goes in, there's an operating arm that'll move the shutters to the right or to the left a little bit, exposing the stationary contacts in the cell, and the breaker will push the whole shutter back around those secondary or the stationary contacts to make the connection. When the breaker comes out, the shutter is closed, so you don't have any exposed 480 volt here. You can't rack the breaker in closed. That's why I opened when it went in. These control connections, I don't know if you ever get involved in this, but the way all of our wiring nomenclature goes is we call it destination wire marking. If it stays in just this cell, you're not going to see any cell information. This wire starts and ends inside the cell. It's going from IOM C34 and landing here on breaker 914. So destination wire markings means that it's labeled with where the wire is and where the other end of the wire is. The IOM is this component right back there. So this wire goes from here to a terminal on the IOM. Over here, this wire here is labeled 5D1 breaker B2, 5C1 breaker B2. So that's telling you it's coming from section 5D1, 5D1 breaker B2. So this is section 1, 2, 3, 4, 5, A, B, C, D. So this wire is coming from 5D1, terminal B2 or B1 on the breaker, and landing here at 5C1, B1 of the breaker. Really makes it easier if you're troubleshooting or if you have to make any modifications, you know exactly where in the circuit that wire is. Over here on the left-hand side of the cell, these are called a code plate or rejection pins. These are arranged so that you can't put an incorrectly rated breaker into a cell. So like you couldn't accidentally put that main breaker at 3200 amps into this cell. This is an 800 amp cell. This is a 1600 amp breaker. You couldn't put a 1600 amp breaker in here. You may or may not be able to put the 800 amp breaker in there because it's not a code violation to put an underrated breaker in a cell. It is a code violation to put an overrated breaker in the cell because the bus supporting this breaker is not built to withstand or to hold up to 1600 amps. So you couldn't put a 1600 amp breaker in there. That bus is certainly okay to support 800 amps. So we don't design it to prevent it, but we don't design it to allow it. You know, it's not sure how to exactly say that, but it could possibly go in there, but it's not designed to. That could not go in here. If you had any other switchboards with these breakers, the other thing you have to look at is the interrupting rating. This is a 65 kA rated breaker. It could not go in place of a 100 kA rated breaker. Again, that would be a code violation. The code plates would prevent that. Any question about any of this so far? That's just a little better view of the barriers. Okay, and then you have the back, the bus compartment. The breaker ends here, the bus compartment's here. And then over back here is the cable compartment. Front, bus compartment, cable compartment. No questions? Okay. Am I that good?
You're good. Oh, no, you're good.
Fire pump breaker. This has a micrologic trip unit also. This is a less functional. It has less functions on it. It's a 3.0. All that is long time and instantaneous. Those were 6.0, long time, short time, instantaneous, and ground fault. This is just long time and instantaneous. Settings is just through the dials. This is got the same type of rating plug there, but you don't. This is not. It doesn't have a P trip unit, so you don't have the voltage connections on here. This is a P frame, J interrupting rating, 1000 amp breaker. Serial number, and this number, all Schneider equipment has what we call date codes. It's a code to show when it was built. This was built in 2018, week 44, day 2. 64 is a plant code, that's Cedar Rapids, Iowa. Padlock attachment. It's a power meter. I showed you before that the base unit's down below, or up above. Base unit's up there. You can see the Ethernet cable plugged into there to go out to a server. You come here, you can get power readings. Power or voltage, current, kW. That you can have alarms set up. It looks like you're set up to go back to a server somewhere for your information. There's probably someone's desk that you can get that. But you can come here and get it in person if you had any reason to want to. And then you can set it up for alarms. You have an alarm, you can go in here and check. No active alarms. If you had an alarm under voltage or sag and you'd want to clear it, once it's corrected, you go to historical alarms, enter, acknowledge all. Those that show it all acknowledged, and hit enter. They were already acknowledged, so didn't do anything, but you can go to the alarm and get all the detail, date, time, stamp, and what it was. If you're going through software, you can pull up a waveform capture to show what exactly happened to generate that alarm. Can't really get the waveform capture through the faceplate. Okay, TVSS. Okay, you don't have any green lights on there. The TVSS is likely not on. If it was on, there should be 3 green lights on there showing good health for the modules. Depending on the interrupting rating of the modules, there's either 2 per phase or 1 per phase. Like I said, they're in the back. As long as they both have good health, you'll get a green light for that phase. If you go back and look at the modules themselves, they'll have green lights. If one of the modules were to go bad, you get a red light here. You look on the modules themselves, one might say green, be green, one would be red. One bad module on a phase will give you a bad phase indication, or bad indication out here. They will go bad, you know, they have a long life, but the more surges you have, the more of that life is used up. It's what happens when you have a surge, the surge arrestor will just shunt some of that voltage off the ground. So it depends on how big of a surge you have, and the duration of the surge you have is how much of that life you've used up. Okay, we have another electric room, I guess right next to here. This is our QED style switchboard. The last one was Power Zone 4. It's compartmentalized. QED is not compartmentalized. If you open up this cover, you're going to have 480 volt bus exposed. So it's really not built for opening up unless you de-energize it. You just have, here you have a main breaker. This has another trip unit. This is just a, it's not nearly as functional even as a fire pump breaker. It's a R-frame 1600 amp breaker, 1600 amp sensor plug. That long time protection is not adjustable on this. The only thing that's adjustable is you have an instantaneous setting here. This is more like a typical breaker. Right here it's closed. If it trips, it's going to go into mid position to reset it, open it all the way up, and then close it. There's a push to trip. This just exercises the mechanical trip. That white button on the master pack breaker sent a signal into the trip unit to simulate a ground fault, so it was an electrical trip. This is just mechanical. It's good to, you know, if you're going through and working on these or exercising, we recommend exercising them once a year still. Nameplate, just like the other ones, date code, like all other Square D equipment. It's not a draw breaker, it's just bolted in, come through. This is our I-line switchgear, or I-line distribution panel. We have a bunch of little breakers and a couple of larger frame breakers. These all, same thing with these, you have the nameplate with all the rating information, serial number and date code. It's made in 2018, week 23, day 2. You have the little red button to exercise it. You do have some trip value, settings here on these. Some of these have trip units, some of them are just thermal mag breakers. Here on these, you can see the trip units. Notice the little green lights flashing here occasionally. The power for the trip units, for the microprocessor in the trip unit, comes from current going through the breaker. So as long as you have about 10% load going through the breaker, the electronics of the trip unit will power up and you'll have that green light. If you notice you don't have the green light here, it's not necessarily a problem unless you know you have more than, if you know that's carrying load, 10 or 20% load or more, and you don't have the green light, then that would be indicative of a problem. For some reason the electronics aren't powering up, but if you don't have any load through it, the green light's not going to be on. So you got 2 of them carrying load. This one doesn't look like it's carrying much in the way of load. Settings here for short time or long time delay, and instantaneous. This is also an I-line. This is an I-line panel board. You have a main, 3 feeder breakers. These are all electronic trip of one version or the other. These are self-powered also. The load going through the breaker is powering up the display here. You're going to have about 10% load going through the breaker for this display to be lit up. Right now it's a 1200 amp breaker, and you got 75 amps going through it, 74, 75. 74, it's not really balanced, but 74, 57, 65. This is, you can scroll through and see what your different phases are reading, but it's going to go back to the default screen, which is going to just show the highest phase reading. These are just like those breakers. This is similar to these breakers, except it also has a display. And the display is you're only going to see information on the display when you have enough load going through the breaker. There is an option to get control power into these. It would be a 24-volt control power. These displays would be lit up and active through the entire range, but that is just an option. You guys, any of you familiar with I-line breakers? Would you guys ever install or remove these breakers? Okay. They're a plug-in breaker. There's a bus stack here. It's A, B, C, front to back. And the breaker, you put it in from the side. On this one, you'd put it in from the side, and you'd lever it in with the screwdriver to engage it, and then there's a screw to screw in the back pan to fix it in place. Any questions about any of these?